Hello and welcome back to Oxford Shorts, where we take difficult ideas from GCSE Science and we try and break them down and give you guys a bit of practice in order to get them right. Today we are going to be covering the very difficult, the very tricky concept of excess and limiting. This is part of quantitative chemistry and it comes towards the end of a unit. If you haven't done the beginning of this unit, honestly, this lesson will make no sense to you whatsoever. So please do make sure you've done those videos first. In order to test that, of course, we have a little starter, which is on your screen now. What I'd like you to do is pause the video, have a go at this question, and then we'll do it together. Okay, so you should have done that question now, and you shouldn't really be listening to my voice unless you've done it. And again, if you don't do these things, then obviously you're going to just learn a lot less. And actually, if you can't do this particular question, then you won't be able to access what we're doing today. So in our last video, I gave you a really nice step-by-step for answering questions like this, which I've got right here. So it's the same question, 10 grams magnesium carbonate, hydrochloric acid. We need to work out the mass of carbon dioxide that's produced. And we had our 6 steps that we did in the previous lesson. Our first step was to balance the equation. In this case, it's pretty straightforward. I just put a 2 over there and I have a look. I've got 2 hydrogens, 1, 2, 3 oxygens, 1 carbon, 2 chlorines, and 1 magnesium. Happy. Now we need to identify our starter and our ender. And I said to you that is based on the question. So if we look here, we've got 10 grams of magnesium carbonate. So that's this. That has to be starter, and it says it's added to hydrochloric acid and calculate the mass of carbon dioxide that's produced. So I know that this is my ender. So I know that I'm starting with 10 grams of this and I'm trying to figure out how much of that I get. Moles starter, so I've got moles mgCO3 equals mass over mR, which equals the mass, which is 10, divided by the mR of magnesium carbonate. I've got a calculator in my hands, and I'm going to add 24 and 12 and 3 lots of oxygen, which is 48, and that will give me 84. So I do 10 divided by 84, and that gives me 0.119 moles. Okay. Next up, I need to do a ratio of starter to ender. So that's mgCO3 to CO2. Conveniently, it's 1 to 1 in this case, because I've got 1 magnesium carbonate, 1 CO2. So I have 0.119 over here. I'll also have 0.119 over there, which means my moles of ender is this, 0.119 CO2. To work out the mass, I do moles times mR. If I remember correctly, that would be 0.119 times by 44. 2 oxygens, 32, plus another 12, brings me up to 44. And that gives me, put it into my calculator, I get 5.24 grams. Or thereabouts. Brilliant. Now, if you got that right, well done. You can carry on with this lesson. If you didn't get it right, I very, very, very strongly recommend that you do not carry on with this lesson and instead you go back to the previous video in this, what's it called, playlist, in this playlist, yeah? So go back to the previous video in this playlist where we go over this, how we do this in more detail. All right, so I've got my, where should I do this? Let's move over to the side over here. So we know that if I start with 10 grams, what we just worked out is that if I start with 10 grams of mgCO3, so I get about, what was it? So about 5 grams CO2. Okay, now let's say though, I took my 10 grams of magnesium carbonate. It's normally it's normally like a powder, right? It's a powder like this. This is my powder, and I add to it 1 drop only of hydrochloric acid. So that's my HCl. You can see that in my equation, I've reacted HCl here with the magnesium carbonate. What I'll do is I'll actually pop that up over here for you. So MgCO3 plus HCl. And then we're getting MgCl2, H2O, and CO2. So I probably should have done that at first. So I add just 1 drop of HCl to magnesium carbonate. Do we think that I'm actually going to get 5 grams of carbon dioxide? Well, probably not, because 1 drop of HCl is enough to react with maybe a bit of the MgCO3, the magnesium carbonate, but it's not going to be enough to react with all of it. 1 drop is not going to be enough to react with everything. In this case, chemists say that the HCl is limiting. It limits the reaction. It holds it back. I'm never going to get 5 grams of carbon dioxide with just 1 drop of HCl. I'd need to use quite a bit more of HCl. I could work out how much, but I know it's going to be more than 1 drop. That much is obvious to me. And we say that the MgCO3 is in excess. Excess means too much. So there's more magnesium carbonate than can react. So what I'll do is I'll add my drop and I'll get a tiny little bit of this and this and this, and I'll have tons of this left over. That's what we mean when we say that it is in excess. 1 second. There we go. Sorry, that's what we mean when we say it's in excess. Now, the flip side, of course, is let's say instead of having 1 drop of HCl, I've got the same amount of MgCO3, and I've got a whole bathtub full of HCl. And I open my little drain over here, and all the acid comes out into the MgCO3. Now, 10 grams of magnesium carbonate is not a lot. And a bathtub of HCl is a lot of HCl. Now, in this case, we would say that the HCl is in excess. There's more HCl than I need. And at the end of the reaction, I'll still have loads of this left over. The magnesium carbonate, on the other hand, is now, of course, limiting. It is what limits the reaction. It's what stops. It's what holds back all of this HCl from reacting. So you might get, the HCl from here. That might be all that reacts, which means you've got all of this stuff left over. And that means it's in excess. There's more of it than you need. If the MgCO3 is limiting, it means it's holding back the reaction. There's not enough. Now, that's a really brief overview about how this all works. But of course, like I said, we do need to do some calculations. Okay, so let's have a look at this. I've got 10 grams magnesium carbonate, and I'm adding that to 10 grams of hydrochloric acid. This is exactly the same reaction that we looked at before. But instead of the question asking me to work out how much carbon dioxide I'm going to get, the question says what is excess and what is limiting. And for this, I have a brand new set of step-by-step instructions that look a bit like this. Now, obviously, the second I put those up, you guys are starting to read all over those. So I'll let you just read them for a sec, and then I'll ask you to bring back your attention to me. So some of that should look quite familiar to you. Balance the equation should be familiar. Starter should be familiar. Ratio, enders should be familiar. This step looks new, and this step looks a bit different. Let me explain to you what I'm doing. First thing I need to do is figure out the moles that are reacting here. Step 1 then, always balance the equation. We did that before, so I'm not going to labour the point. Now it says reactant 1 should be starter and reactant 2 should be ender. When it comes to excess and limiting, you have to decide what's the starter and what's the ender. And in reality, you can pick this as your starter and this is your ender, or this is your ender and this is your starter. I say just to make things easier, always pick the first one as the starter. So we'll call this one the starter, and we'll call this one our ender, just for the sake of ease. mole starter. So we know moles, not males, silly. So that should be moles equals mass over mR. And actually we've done this earlier. We did it up here. So we had 10 over 84, which gives us 0.119. Now, I'm not asking you any questions while I'm doing this because I really just want you to be focused on me and what I'm doing. In the next example we'll do, I'll ask you to do bits and pieces for yourself. Our ratio is MgCO3 to HCl, which in this case is 1 to 2, because I've got an imaginary 1 in front of here and an actual 2 over there. Now, what that means is that if I put 0.119 moles here, I'm going to have twice that amount over here. So I take out my trusty calculator and I go 0.119 times by 2, and it gives me 0.238. And again, there's an entire video about this, so I'm not going over it now. There is an entire video about how I work that out, so I'm not doing it now. All right, so what that means is that my moles ender equals 0.238. My mass equals the moles times the MR, which in this case is 0.238 multiplied by the MR of HCl, which is 36.5. And I plug that into my trusty calculator, and I get 8.687. Now, what does that represent? This number that we've just worked out represents how much HCl I need to react with this mass of magnesium carbonate. We've completely ignored this, which we can do for the minute. This only comes up right here, so we can ignore that completely. The question is, if I've got 10 grams of magnesium carbonate, so I've got 10 grams of that, how much of this do I need? That's what we've done so far. If I've got 10 grams of this, how much of this do I need? I need this much. I can now go back to the question. I need this much, 8.687 grams of HCl. I have 10 grams. So in the question, they've given me 10 grams of HCl. I don't need all that HCl. All the HCl I need is 8.687, which means I've got more HCl than I need. I've got 10 grams, but I only need 8.687 grams. And therefore, HCl is in excess. Now, this last sentence here is a writing frame. It's a writing frame. If you always use this sentence, you will never get it wrong. You can add to it, if you like, that MgCO3 is limiting, but for the minute, we're just going to leave it as that. And if you have that sentence at the end with those blanks and you just fill them in based on what we've done here, you will get all the marks and you will not make any mistakes. If you start faffing around and using a different method or skipping steps or not using this writing frame, I guarantee you, you will make mistakes, you will drop marks. So let's go and have a look then at another one to do together. I've now got 17 grams of methane reacting with 20 grams of oxygen to make carbon dioxide and water. Now, at this point, normally in a question, they'll give you the equation. And so what I will do is I will write out the equation for you. Though, of course, if you feel confident writing that equation yourself, pause the video and do it. But I am going to give it to you here. So it's CH4 plus O2 forming CO2 plus H2O. First step. What we're going to do is we're going to do this step by step. You're going to do it with me. So you're going to do a step, then I'll do the same step. You're going to do a step, then I'll do the same step. So first off, we're going to balance the equation. So I'd like you to pause your video, balance the equation. You should only now be watching the video if you've balanced the equation. I've got 1 carbon here and 1 carbon here, so I'm happy. 4 hydrogens there, but only 2 there. So I'm going to add a 2 here. Now I've got 2 oxygens there, 4 oxygens here, so I'm going to have 2 over there. We say that reactant 1 has to be the starter and reactant 2 has to be the ender. So this one here must be starter, and this one here we're going to make the ender. I'd like you now to work out the moles of starter that you have. Pause the video and work out the moles. You should only now be listening to my voice if you've worked that out. So moles equals mass over mR. The starter is CH4. I've got 17 grams of CH4. So that would be 17 divided by the mR, which is 16 for CH4. I plug that into my trusty calculator. And it gives 1.0625. 1.0625 days. My ratio here, actually, sorry, of course, I'd like you to do the ratio for me, please. So you can do steps 4 and 5, do the ratio of methane to oxygen, and work out the moles of oxygen that I'll need. Pause your video and do that for me. Okay, you should only be listening to my voice now if you have done that. So we've got CH4 to O2, which is 1 to 2, which means if I've got 1.0625 here, I need to double that. So I use my trusty calculator. Yes, 2.125. So I know that my moles of O2 equals 2.125. What I'd like you to do now is work out the mass of that ender. So you're working out the mass of 2.125 moles of oxygen. So you should pause the video and work out that mass. You should only now be listening to my voice if you've done that mass. So we know that the mass is the moles times the mR, which in this case is 2.125 multiplied by 32. It gives me 68 grams. This is the hard step now. What that means is that this is how much oxygen I need to react with this much methane. So if I have 17 grams of methane, 17 grams, look in the question, if I have 17 grams of methane, I need 68 grams of oxygen. So I can fill that in over here. Let's kind of make it a bit bigger for you. I need 68 grams of oxygen. How much do I have? Oh, well, that's in the question. I have 20 grams of oxygen. Now, that is clearly not enough oxygen. If I need 68 and I've only got 20, it's clearly not enough. So O2 is therefore what? Speak out your answer, please. O2 is therefore limiting. And it's limiting because I don't have enough of it. It's what limits the reaction. What I'd like you to do is pause your video and copy this down as an example. So it's really important you have nice worked examples. So make sure you write out the question, write out the steps, and write out the working really clearly, and make sure you've got that writing frame as well. Okay, let's try another example. Before we do that, you might have noticed there's a slight typo in my writing frame, which I made such a big fuss out of and then made a mistake in it. It should just say is. I've deleted that from the next ones coming up. So it should just say, therefore, O2 is limiting. Brilliant. Right, let's have a look at this one. Now, like we did before, what I'd like you to do is you're going to do some steps for me, and then we'll go over them together. So first off, I'm just going to give you the equation for that. It's Al plus F2 to make AlF3. First off, I'd like you to pause your video, balance the equation. Okay, you should only be listening to me now if you've balanced that equation. You should have 2 over there, 2 over there, and what looks like a 3 over there. This here is my starter, and this here is my ender. What I'd like you to do now is work out the moles of starter, please. Work out the moles of starter. Okay, you should only be listening to my voice if you've done that question. So we've got moles equals mass over mR, which in this case is 28 divided by the mR of aluminium, which is 27. So I do 28 divided by 27, and that gives me 1.037. Very nice. And then next up, I need to do my ratios. I'd like you to pause your video and do the ratio for me. So you should have Al to F2, and the ratio of 2 to 3, which means if I've got a 1.037 there, what I've done is divided by 2 and times by 1.037. So do 3 divided by 2 and then times by 1.037. Again, if you have no idea how I did what I just did, well, we've got a whole video earlier on in this playlist that deals with that. So go back and do that one if you did not get this and have no idea what I just did. So the moles of ender, that means I've got 1.5555 moles F2. I'd like you now to work out the mass of fluorine, please. Pause the video, work out the mass of fluorine. Okay, so the mass of fluorine should be moles times mR, which equals, so let's pull this aside, 1.5555 times by the mR of fluorine. So fluorine is 19, so 2 of them are 38. 59.109 grams. Now what I'd like you to do is have a go at filling this out yourself, please. Pause the video, fill this out yourself. All right, I'm hoping you got that right, where it says I need 59.109 grams of F2. How much do I have? Well, it says I've got 49 grams. And therefore, F2 is what? Well, if I've only got 49 and I need 59, F2 is emitting. Bing, bang, bosh. Done. If you got that right, and you got all of those steps as we were going through them, well done. If you didn't, make sure you go back in careful detail. Each of these lines, as I said, is a previous video. So there's a previous video on balancing equations, this is a previous video on moles, previous video on ratio, previous video on how to work out the moles of ender. So do make sure you go back and do those. I've now got some questions, and I'd like you to pause your video and have a go at these questions, and only press play once you have done all the questions. Okay, so what I'm going to do is I'm going to go through the answers, and I've got working for you. So what I'll do is I'll just put them up, and then you can pause the video for each one, check your working. So there's the first one, pause your video and check. I'm moving on to the next one now. There's the next one, pause your video and check. I'm moving on to the next one. There's the last one, pause your video and check. As ever, thank you so much for listening. Please do remember to subscribe. And if you have any particular topics that you want me to do, you can suggest those in the comments. Thanks again. Bye for now.